Hi everyone, thank you for joining me today. In this demo, I'll walk you through PACX, our AI-powered, fully automated predictive analytics platform that transforms raw data into precise, actionable insights. Whether you're in e-commerce, marketing, finance, supply chain, or retail, PACX helps you anticipate trends, optimize decisions, and drive measurable results. But instead of walking you through every feature, we're going to take a practical use case and go through it step by step, just like a real user would. This is our PACX landing page. First, we create a test account. After logging in, we head to the Launchpad where we access our ML Studio. In the Studio, first, we have data sources. You can connect to external databases like PostgreSQL, cloud storage like Amazon S3, or even upload a local file directly from your system. For this demo, we'll connect to a mock PostgreSQL database, import data from a table, and preview it. There's the ETL workflow section. This is where you can extract, transform, and load your data before modeling. It's super intuitive. Here you can see a visual summary of the dataset we just imported. PACX automatically generates insights for each column, including data types, unique value counts, missing values, and distribution charts. For example, you can quickly observe patterns in product ID, category, and daily demand, and see the date range in the date column, all without writing a single line of code. This is a time series dataset, well suited for demand forecasting. Our objective is to predict the weekly demand for each product over the next 30 days, a critical task for effective inventory and supply chain planning. Let's go back to the studio. PACX offers two flexible workflows: a GenAI chat-based flow designed for non-technical users, a hands-on mode built for data-savvy professionals. Both workflows use the same powerful predictive engine, but the interface adapts to your experience level. For this demo, we'll start with the GenAI chat-based flow. This mode is ideal for business users who may not be familiar with data science techniques. It allows you to describe your goal in plain language. And the AI handles the rest. It intelligently interprets your request, guides you through clarifying questions, understands your data, and configures the predictive setup for you, all through a simple conversational interface. It's fast, intuitive, and eliminates the need for any data science skills. You can start by simply typing something like, "I want to forecast product demand." The AI responds with clarifying questions like, "Do you mean weekly demand? Over what time period?" Through this natural back and forth, the AI helps you refine your predictive objective without needing any technical input. Next, it automatically detects your previously imported dataset, or prompts you to upload a CSV file if needed. PACX then analyzes the data schema, assigns the correct data types, identifies the entity column, e.g. product ID, suggests the target column, e.g. demand. You can review and confirm these suggestions or make changes. Once finalized, PACX enables the Generate Notebook button, which prepares your data for modeling. Clicking the Open Notebook button takes you to the Notebook tab. PACX automatically generates a SQL-based notebook tailored to your predictive objective. The goal of these queries is to prepare and transform the dataset to match the prediction task. This notebook includes pre-written queries, filtered and sampled data, validated entity and target columns. All cells are fully editable. You can update the time frame, adjust the frequency, or remove any unnecessary columns. The notebook dynamically adapts to your changes. Once you're satisfied, click Train Model. This will save the notebook and its schema. Launch the model training pipeline. After training begins, PACX takes you to the dashboard, where you can monitor progress in real time. Here's what you see on the Model Leaderboard tab: a summary of all trained models, including key performance metrics for each. Training R-squared, how well the model fits the training data. Validation R-squared, used to check for overfitting or underfitting, test R-squared. The final measure of how the model will perform on unseen data. The best model is automatically selected and deployed for future predictions, ensuring you're always using the most accurate and reliable model going forward. Once training is complete, PACX automatically identifies and highlights the best performing model in this case, XGBoost, and deploys it for future predictions. From there, you can explore a wide range of insights through the Model Evaluation Dashboard. PACX presents results through clear visual dashboards organized into the following key sections. Metrics analysis, summary of key metrics like R-squared, root mean square error, mean absolute error, and more performance consistency, shows how stable the model is across different time periods or groups. Feature importance, highlights which features had the most impact on predictions. Residual analysis helps you understand the errors and where the model may need improvement. Test set predictions shows actual prediction outputs on your test dataset for validation. For example, you might see that Product 1 is forecasted to sell 150 units next week, with a plus or minus 5% error margin. This level of insight gives planners the confidence to make accurate restocking or supply chain decisions. Additionally, PACX provides trend charts, weekly demand forecasts, and feature importance visualizations, making it easy to interpret results and communicate them with stakeholders. You can now explore other tabs like training progress, feature analysis, and model comparison to dig deeper into performance insights. Now, let's move on to the Predictions tab. Simply upload the latest product data. PACX will automatically apply the selected best model generate weekly demand forecast for the next 30 days. After the predictions are generated, let's take a look at the predicted table. Here you'll see detailed outputs including the product ID forecasted demand per week, prediction timestamps. For example, 21,470 units forecasted for product 1 in week 1, 20,000. 300 units forecasted for product 10 in week 2, and so on. You can view the predictions directly on screen, and if needed, download the results as a file for further use. Whether it's for internal reporting, dashboards, or integration into downstream systems, with PACX, generating accurate, actionable forecasts is no longer limited to data scientists. It's fast, intuitive, and accessible to everyone. That brings us to the end of our walkthrough. Thank you for watching.